Welcome friends, this is Dr. Prashant Patil, Jain College of Engineering, Belagavi. Please subscribe my channel, leave the comments and also don't forget to hit the like button. In this video, we are discussing on inverse Laplace transforms. Come friends, in this video, some more examples on inverse Laplace transform of the function f of s minus a type. That is by completing square type I am going to do. That property is nothing but inverse Laplace transform of f of s minus a. I can find it as, but wherever s is there, it should be s minus a. E to the power at into inverse Laplace transform of f of s. That means s minus a is replaced by s and extra you have to multiply e to the power at. Okay, example on this one I am doing. Find inverse Laplace transform of 7s plus 4 divided by 4s square plus 4s plus 9. Here denominator is not a perfect square or factors are also not available. That's why what I will do, adjustment here is consider, I will try to convert it in terms of perfect square, completing square type. Consider 4s square plus 4s plus 9. First of all, s square coefficient I will try to make it as 1. That is, I will take a 4 common. 4 into bracket s square plus s plus 9 it has become. Okay. 9 divided by 4. Now, here to make it as a perfect square, that is of the type a square plus 2ab plus b square type, then I can replace it by a plus b the whole square. Here 4 into s square is there plus 2 is not there. Okay, only s means a is there, 2 is not there, b is not there. To adjust, what we will do, 2 into s is already there, that extra 2 I multiplied, therefore I will divide by 2. Okay, this will act as my b now, 2ab, correct, 2 will remain, but this will act as b plus b square I want. B is 1 by 2. That is 1 by 2 square I have extra added. I will subtract 1 by 2 the square also. Plus 9 by 4 as it is there already first. Okay. Using these first three terms, they are looking like this. Therefore, I can replace them by this one. That is 4 into s plus 1 by 2 square I can write, correct, using the first three terms, and subtracting this minus 1 by 4 plus 9 by 4 will become 9 by 8, sorry 8 by 4 plus 8 by 4, or 2 ones are 2 twos are, it will cancel, correct, 4 ones are 4 twos are, that is nothing but 4 times s plus 1 by 2 the whole square, okay, plus 1 by 2 the whole square plus 2. I will write as it is this one. Okay, this is denominator. Therefore, inverse Laplace transform I can write. Inverse Laplace transform of 7s plus 4 divided by 4s square plus 4s plus 9. I can write it as inverse Laplace transform of 7s plus 4 divided by 4 times s plus 1 by 2 the whole square plus 2. You can just observe here, to apply that property, wherever s is there, it should be s plus 8 or s minus a type. Denominator only I am getting, but the numerator is of the form only s is there. That's why this one also I will convert it into s plus 2 type. To make that one, inverse Laplace transform of denominator is, or 1 by 4 I will take common, 1 by 4 s plus 1 by 2 the square plus 2. Numerator you can check, 7 s is there, I want to make s plus 1 by 2, 7 times s plus 1 by 2. Therefore, I have added here 1 by 2, not only 1 by 2, you can just observe here, I have added 7 by 2. Therefore, I have to subtract 7 by 2 to retain the same equation. Okay, plus 4 as it is. Therefore, simplify this. I'm going to get it as 1 by 4 times inverse Laplace transform of 7 times s plus 1 by 2 plus here LCM is 2. 2 into 4 is 8. 8 minus 7 is 1 by 2 plus 1 by 2 whole divided by s plus 1 by 2 square plus 2. Its inverse Laplace transform. Now I can apply the property. Inverse Laplace transform of f of s minus a is equal to e to the power at into inverse Laplace transform of f of s. That is s minus a is replaced by s. And here a is equal to 1 by 2. S plus 1 by 2 is replaced by s. Okay. Which is equal to this one. I will replace it by s plus 1 by 2 is replaced by s. That I am going to get it as 1 by 4 times inverse Laplace. Sorry, I have to multiply e to the power 80. That is e to the power minus 1 by 2 into t inverse Laplace transform of 7s plus 1 by 2 divided by, and this is s square plus 2 e to the power 80. Don't forget to multiply this. Therefore, next I am going to get e to the power minus t by 2 divided by 4. Okay, into, I will split it into two terms as inverse Laplace transform 7 I will take outside, s divided by s square plus 2 plus 1 by 2 into inverse Laplace transform of 1 divided by 1 by 2 taken common, that is s square plus 2. That is nothing but e to the power minus t by 2 whole divided by 4 into bracket 7 into inverse Laplace transform of s divided by s square plus 2 square must be there, but it is 2. That's why I will adjust this one as inverse Laplace transform of s divided by s square plus root 2 the square plus 1 by 2 inverse Laplace transform. Here also I will write as it is s square plus root 2 square. Okay, now I can simplify this one as e to the power minus t by 2 divided by 4 into 7 times s divided by s square plus a square, that is cos of root 2t, correct? Cos of root 2t plus 1 by 2 is there already, and this one is 1 by root 2 into sine root 2t. Okay, this is the required answer for this. Okay, like this. Another example I am solving here, very simple, and how to adjust is very important. Example is inverse Laplace transform of 2s plus 1 divided by s square plus 3s plus 1. Here again denominator is not in the perfect square. I have to adjust it. Consider s square plus 3s plus 1. Okay. Here to make it as a perfect square of the type a square plus 2ab plus b square, I have to make it as. But here s square plus s is a is my 2. Therefore 2 into a is s. B is nothing but 3 by 2 I will take. 2 cancels, 3s will remain as it is. That's why I have to multiply and divide by 2. This is 2. This is my b now. That's why what I will do to get b square, 3 divided by 2 the whole square I will add and subtract 3 by 2 the whole square plus 1 will remain as it is. Then combining first three terms I can write it as s plus 3 by 2 the whole square, and LCM is here 4, that is minus 9 plus 4, minus 9 plus 4 will become minus 5 by 4, correct? Minus 5 by 4. This is the adjustment of this. Then using this denominator here, inverse Laplace transform. Or one thing also I will do, now denominator is in terms of s plus 3 by 2, numerator also I will adjust in terms of s plus 3 by 2. Consider s 2s plus 1 equal to 2 into s plus 3 by 2. I have added 3 by 2, not only 3 by 2, 2 into 3 by 2 I have added. Therefore, I have to subtract 2 into 3 by 2 plus 1 is already there. That's why what it will become then? 2 cancels. This is nothing but 2 into s plus 3 by 2, s plus 3 by 2 minus 2. Numerator. This is denominator, this is numerator. Okay, now I can write inverse Laplace transform of 2s plus 1 divided by s square plus 3s plus 1. I can write it as inverse Laplace transform of 2. I can take common here. Okay, I will write it as 2 into bracket s plus 3 by 2 minus 1 whole divided by s plus 3 by 2 the whole square plus 5, sorry, minus 5 by 4. Okay, this is of the form now. Okay, this equation is of the form inverse Laplace transform of f of s minus a form. Correct? Here I have to find out e to the power at into Laplace inverse Laplace transform of f of s. That is s minus a is replaced by. Comparing with this, a is equal to minus 3 by 2. Correct? A is equal to minus 3 by 2 and s plus 3 by 2 must be replaced by s, which is equal to e to the power at. A is minus 3 by 2 into t inverse Laplace transform of s plus 3 is replaced by s. That is 2 into bracket s minus 1 divided by s square minus 5 by 4. Correct? S plus 3 by 2 is replaced by s. Now its inverse Laplace transform can be calculated easily. Okay, just I will do it as I will take 2 common here. 2 into e to the power minus 3t divided by 2 into I will split it into 2 terms. Inverse Laplace transform of s divided by s square minus 5 by 4. One term minus inverse Laplace transform of 1 divided by s square minus 5 by 4. 1 divided by this minus. These inverse Laplace transforms I have to find out, which is nothing but 2 times e to the power minus 3t by 2 into inverse Laplace transform of s divided by s square minus a square. How can I convert it in terms of a square here? That is inverse Laplace transform of s divided by s square. This I can write it as root 5 divided by 2 the whole square. Am I right? 5 by 4 I can write it as root 5 divided by 2 the whole square minus, and this one I can write it as inverse Laplace transform of 1 divided by s square minus root 5 divided by 2 the whole square. That is 2 into e to the power minus 3t by 2 into minus is there. That's why it will look hyperbolic. This is s is there, therefore it is cos hyperbolic root 5t divided by 2 minus, and here 1 divided by is there, therefore it is a sine hyperbolic, and this will become multiplied. 1 divided by root 5 divided by 2 into sine hyperbolic root 5 divided by 2t. I'll just write it once again, adjustment terms. 2 into e to the power minus 3t divided by 2 into cos hyperbolic root 5t divided by 2 minus 2 by root 5 into sine hyperbolic root 5t divided by 2 is the required answer. Okay, like this Another example, simple and fast I'm doing here. My next example is find inverse Laplace transform of s square divided by s plus 3 the bracket cube. This one I can use it by partial fraction also, because s plus 3 cube is there. I can write it as s square divided by s plus 1 into s plus 1 into s plus 1, like that. Three terms we have to find out, or their partial fractions will become s plus 1 cube is nothing but as square plus bs plus c divided by s plus 1 cube. Then I have to find out the values of abc. In spite of that, I will do perfect squaring type. Okay, here to apply this property, that is e to the inverse Laplace transform of f of s minus a. Okay, here s minus a is there. Numerator I have to adjust it as in the form of s minus a. That's all. Consider s square equal to, I have to adjust in terms of s plus 1. Okay, how can I express this on s plus 1? To make it as, I have only the term s square. To make it as a square plus 2ab plus b square. These two terms are missing here. What I will do? S square plus 2a. A is nothing but s. Okay, plus b. B I will choose it as 1. Can choose 1. Correct? I will choose b as 1 here. 2ab. Okay, plus b square means 1 square. These two terms I have added here extra. Therefore, I have to subtract those terms. What I have added here? 2s I have added, minus 2s minus 1 square. I have to subtract. Then it will become, first using first three terms again, I will become s plus 1 square minus 2s minus 1. But again s is remaining here. This s also I have to make it as s plus 1. That I will make it as s plus 1 square minus 2 into s plus 1. What I have subtracted, minus 2 into 1. I have subtracted minus 2s. Sorry, minus 2. Therefore, I have to add 2 minus 1 as it is. This is my adjustment. Okay, plus 2, because minus 2 into 1 I have added. That's so therefore I have to add here, which will become s plus 1 the square minus 2 times s plus 1 plus 1 is my required answer. Okay, what is that? S square I can write like this. Correct? S plus 1 the whole square minus 2 into s plus 1 is my s square. I can write like numerator I am adjusting here. Denominator is already in the form of s minus a. Therefore, consider inverse Laplace transform of s divided by s plus 1 cube. I will write it as s square. This s square I will write it as inverse Laplace transform of s plus 1 the whole square minus 2 into s plus 1 whole divided by, denominator will remain as it is, s plus 1 cube. Now you can check all the terms, wherever s is there, it is with s plus 1. Okay, now I can apply this property and I can write it as e to the power at into, sorry, my at into inverse Laplace transform of f of s. This property I can use now. Okay, to use that, here a is equal to minus 1 and s plus 1 should be replaced by s. That is e to the power minus t into inverse Laplace transform of s square minus 2s. S plus 1 is replaced by s plus 1 as it is divided by s cube. Okay, its inverse Laplace transform can be calculated easily. That is e to the power minus t into, split the terms, inverse Laplace transform of s square divided by s cube minus 2 into s divided by s cube plus 1 divided by s cube, which is e to the power minus t into inverse Laplace transform of 1 by s minus 2 by s square plus 1 by s cube. To find out its inverse Laplace transform, I am using the property of I'm using the property inverse Laplace transform of 1 by s to the power n is t to the power n minus 1 divided by n minus 1 factorial. That is e to the power minus t into s to the power n. N is 1 here. Therefore, t to the power 1 minus 1 divided by 1 minus 1 factorial minus 2 into s, 2, s n equal to 2 again. Therefore, t to the power 2 minus 1 divided by 2 minus 1 factorial plus t to the power 3 minus 1 divided by 3 minus 1 factorial, applying this property. E to the power minus t into t to the power 0 is 1 divided by 1. 0 factorial is 1, therefore it is 1 minus 2 into t to the power t minus 2 is 1 divided by 1 factorial is also 1 plus t square divided by 3 minus 1 is 2. 2 factorial is 2. This is the required answer for the particular answer. Okay, like this, some more examples on inverse Laplace transform I'm going to solve. Please subscribe my channel, give the comments, and also don't forget to hit the like button. Thank you friends.